Hey there, this is the fourth video of the Global Sensitivity and Uncertainty Analysis series. My name is Tori Morgan and I'm a PhD student at the University of Florida in the Department of Agricultural and Biological Engineering. I use GSUA in my own research, so I hope this video can help you use GSUA for a class or the research that you desire to do. So we've already learned how to create a FAQ file and how to create the SAM and matrix file to be used for running your model through GSUA on the high performance computer. So now we will open up our file sharing platform. So I'm going to do a quick connect on FileZilla. And I'm going to open up the GSA files. And now we can log on to the HiPerGator. So in order to do this, you're going to want to open up a console. I have terminal up and running on my Mac. And the code for this is SSH space your username or GatorLink account at hpg.rc.ufl.edu. And then it's going to ask for your GatorLink password, so you'll just enter that. And it should take you to this screen. If it blocks your permission, you should probably talk to the person who gave you authority to use the HiPerGator. If you're in the biosystems course, you should talk to Dr. Carpena about giving you permission to log on to the HiPerGator. So now we can take a look at the files in our terminal. And this is just by changing the directory to our where your class directory is located. So mine's just under my username, and I'm going to change the directory to 2018, and I can click Tab to quicken that. So CD, your class folder, LS. And so I've run previous jobs on this folder, so I can remove some of these. The only thing is you have to be very careful about removing jobs in your FileZilla account or file sharing platform and on the terminal, because there is no backup system and there is no trash can where you can go and retrieve these files if you deleted something by accident. I'm going to go ahead and remove .job and remove *.out. So I can see my FAQ folders here, my TXT, and my matrix folder. I'm going to delete this real quick so I can show you. If you have a TXT file that's not named matrix file, how to convert it to a Unix format and direct it to the matrix.txt. In order to do that, it's just going to be dos to Unix, and then the name of your file. So mine is adult.crc.txt. So it's converting it to a Unix format, and then I'm going to code ln space s, and then again the name of the file, and then space matrix.txt. And if it doesn't give you an error, that's a good sign, but you can also check to make sure it worked by typing ls space dash or -la. So the matrix file is pointing to the file I want. Now we can make our jobs, but before we make the jobs, I want to give some background on how to make jobs and what things you should consider. So the two questions you should ask yourself when making jobs is, what is the timeline? So how long can you wait for the jobs to come through and the model to be run? And what is the timeline for the project? Do you need this by tomorrow? Do you need this by next week? Or do you need this within a few hours? The other question to ask yourself are, what are your resources? So if you're in the Advanced Biosystems Modeling course with Dr. Carpena, Dr. Kiker, and Dr. Huffaker, then you have 300 cores that you're sharing with the entire class. So you may only be able to use 5 to 20 cores at a time. So therefore, you need to be reasonable and respectful for how many cores you are requesting in the system. Because if you use up all the cores, then someone else will not get to use them. Also, it doesn't really help if you request more cores and someone else requests less cores at the same time, because the task manager will put your project on the back burner compared to someone who will take less time and request a less amount of cores to complete their project. So for this example, there are 14,927 simulations. My time frame is 12 hours, so I finished at 8 p.m. and I want my model run by 8 a.m. And then the number of cores I have available to myself is 100. So then you have to figure out how long does it take to run one execution. And if you're not sure, you can always run this code, time space Java space hyphen jar space program, and it'll tell you how long it takes to run an execution. My own model actually takes about less than a second, but depending on how heavy your model is, it may take seconds to minutes to hours. So in this situation, it takes 45 minutes. So that means for one job, if you divide 45 by 60, it takes 0.75 hours per simulation. So I said my time frame was 12 hours. So what we will do is divide 12 by 0.75 to get 16 simulations per job or per core. And the code executed for this will be sh space make underscore jobs.sh, the number of your simulations, and then the number of simulations per job. So we have 16 right here. So it'll be sh space make underscore jobs.sh space 14,927, because that's the amount of simulations I said I wanted to run. And this has to match your SAM and TXT file. So there should be 14,927 rows. And then 16 is what we calculated from here. But how do we know how many cores we are using when we do this? Well, if you divide the simulations by the simulations per jobs, you will get the amount of cores. So we're using 933 cores. So the question is, did we exceed the amount of cores given? Well, we were given 100 and we're using 933. So yeah, we definitely exceeded the number of cores. So our project could not run at all, and it could kick us out of the system, or we could be infringing on someone else's cores that we are sharing. So if you want to figure out maybe your model's like mine, where it doesn't really take that long to run, so you're not really concerned about time, but you want to be more concerned about cores. So if there's 100 cores, what you can do is divide the number of simulations by core, and then you get 149.27. If you insert this into this code, you will want to round up, so it'll actually be 150. So it'd be the same thing, except for using 16, you would use 150 simulations per core. So now that we know how we make jobs, let's put this into our code. So real quick, I'm going to change the directory to my base. I'm going to do module load UFRC, and then Java space jar water CR. Oop. Be very careful about what you type. .jar. So now my module's loaded, my Java is loaded. It gives this error, but it still works anyways for my model. So just be aware of the errors. And now we are going to type sh make jobs.sh. And for the model I'm currently running, it has 19,965 simulations. And I'm going to type 100. So right now it's creating all of those jobs, and that's why it was important to have the if you remember from the last video, the top and bottom, because this is going to put sandwich all the jobs together. After it makes the jobs, we'll want to submit them to the task manager. So sh class underscore submit.sh. And now it's submitting all the jobs. If you want to find out how many jobs are still kind of in the queue, you can type sque space -u and then your username. So there's still a lot of jobs out there that are being completed. So while that's completing, I'm going to show you what to do once you get your outputs. So this is what it's going to send. It's going to show up in the outputs folder, and it's going to be output.all, actually output_all.txt, I believe. We'll see when it finishes. But you'll just open up that file, and it'll look like this. If you want to run it in SimLab, you're going to have to change the format. And how to do that is the first row should be the amount of outputs you have. So you see I have 2 columns of outputs. So then it's going to be 2. And then you want to label what those are. So the first column corresponds to water dose. And my second column corresponds to hazard quotient. And then you're going to type time equals no, and then how many simulations you have. So I have 19,965 simulations. So then we want to save that. And then you can open SimLab, which I'm going to open with my wine package. In order to conduct the sensitivity analysis, you'll want to load your sample file. So adultcrc.sam, configure Monte Carlo, select model, and then the output file we just created. So we had to change the format of the file so that SimLab could recognize it. And I believe this is on my desktop. So start Monte Carlo, and then you can analyze the uncertainty and sensitivity analysis. So I'm going to just look at the hazard quotient. So add new variable. And I can look at the sensitivity analysis. It shows this pie chart and how much of the pie the factors are taking up. So you see the biggest one looks like it's probably the days or the weeks, which I can tell by this legend right here. It also shows the first order and the total order. The first order are the independent factors and how much variance they explain within the model. The total order is the global portion of the global sensitivity uncertainty analysis. And that explains how much variance the interactions between the factors explain. So the total order is the interactions, and the first order is the factors independently. And then I can look at a table of it, and if I want to, I can save the table so that I can open it up in Excel later. Save. Now let's see if it finished running our jobs. You could also look at the uncertainty analysis, and it just shows you the distribution. So I see that most of my results are between 0 and 0.1, but there are still some results at 0.2 and 0.3. So let's see if it finished. There's still a few more left. And then for my uncertainty analysis, I usually copy all of the outputs from that output file we're looking at. So I'd copy this and put it into Excel, and that's how I can compare the uncertainty of the model and see how much is below or above the value I was looking for. So I can close out of SimLab. So this shows that there's one more job out there. And it shows the time that it takes to complete each job. So the whole model is taking about 5 minutes to complete. Okay, now it's finally completed, so we can look at our outputs. Before we do that, we have to we have to change the directory to our outputs directory. It's this one I was showing you right here. You see all those jobs that were completed, and then we'll type sh class merge, class_merge.sh. And so now if we refresh in here, we see our output file that I showed. So it is output_all.txt, and we can rename it. This was just the same file I was showing you earlier, so adult CRC. And then you can save it to your desktop. So now you have successfully, hopefully, run your model, and you can view your outputs through SimLab or Excel and conduct your own global sensitivity and uncertainty analysis. Thank you for watching this video, and the best of luck with your research.